So one of the things I always end up with project I work on is like, how am I going to get power and ground to everything? And what I think the main thing you got to keep in mind is you really want the power and ground values to stay as close as possible to each other across the components. And so in that case, I'm going to suggest that really you want to do like a home run, if possible, power and ground back to the same point, as close to where the power comes into the system as possible. So in this case, what I do is I end up creating these little header arrays on a piece of perf board, and I'll show you that in a minute. And basically here I've got a processor, some NeoPixels, a motor driver circuit, and a servo, and they all need 5 volts. And so I have 5 volts coming in. What I do is I try and I could solder all of these directly to I actually did that on one, solder it directly to this jack. This is a barrel jack here. And so you could run all of them back to that directly. I tend not to like that. The last one I did, I ended up with this big blob on the barrel jack. And they were all kind of soldered to it. But in my case, for the project, the rework of that, I ended up creating basically power and ground buses. And this 3.3 volt bus exists just so that in case I need to tap off of the 3.3 on the microcontroller. But basically the idea is I want to create a home run point for power and ground, right? And the reason I want to do that is what we don't want to have happen is any kind of ground loop or any place where the grounds, like in this case here on a NeoPixel, you can have ground on the way in and ground on the way out. And depending on how that might work, that might be a bad idea, right? The ground where you start up here could be different than the ground level at the end. The goal is to make the ground level as close to the same as possible and then tie back the voltages. So like the 5 volts that everybody gets as close to 5 volts as you could expect, right? So this pattern here I've used a couple times, but you can run into really weird issues. If one of these really jacks on the power here, it's going to drain the ones past it, whereas if you do this, you could put capacitors across all those connections independently, and no activity on one of the others is going to be serially connected through that. But the main idea here is create a bus, create a star configuration for power if possible. And in this case, I used created connectors, and I do that. You know what? Let me show you. So this is an example. This is a 5 volt and ground and a 3.3 volt power plane. And I just did this little piece of perf board. I've got some connectors, and I try and bring the power in close to the center of each connector as possible. You can see I've got 5 grounds and 4 power. Actually, after this picture, I added a 5th power. So I have 4 devices in the barrel jack. That's 5. So I need 5 wires. And so I create little backplane for these. And then on the back of the perf board, you can see that this is flipped over. So this is the power with only has 4. I ended up adding another one on the end and adding another wire in that connector. And then the ground has 5 and the 3.3 has, I don't know how many are there, 3. And those aren't used right now because it turned out the motor I was using draw too much 3.3 volt power from the microcontroller. So this was a great case of not having soldered it. I just moved the pins for the motor controller over to the 5 volt. So that's it. The main thing is do a home run based wiring if possible. You don't want super long lengths, but the idea is to bring everybody back to the same level of ground, especially and power if you can. And that's it. So just do a little perf board thing. I'm sure there's better ways. Add a comment or send me an email if you think there's another simple way to build a bus for this. And then I just use all these little connectors everywhere. Takes up a little more space than soldering, but it lets me rework it. Have a great day.